Composition of the Milky Way. From the center out. The Milky Way is composed of many different elements. Our galaxy, being as relatively mediocre in size as it is home to 100 to 400 billion stars, along with nebulae, asteroids, dust, and gas. At the center of our galaxy is a black hole. Let's start there. At the heart of the Milky Way galaxy lies a supermassive black hole. Scientists call this black hole Sagittarius A. It's roughly 4 million times the mass of our own neighboring star, the Sun. Most elliptical and spiral galaxies have a black hole at their cores. Sagittarius A has a diameter of about 43.9 million kilometers, 27.3 million miles. That's roughly the same distance from Mercury to the Sun. Our galaxy depends on the gravitational force of this black hole. In fact, it's the reason the Milky Way spins at about 270 kilometers, 168 miles per second. Just beyond Sagittarius A live massive star clusters. These star clusters contain stars that originated around the same time and in roughly the same way. Astronomers have named some of these clusters arches, quintuplet, and GC star clusters. These clusters are incredibly bright and are constantly colliding with molecular dust to form more massive stars near the middle of our galaxy. Throughout our galaxy, and embedded within the billions of stars, you will find galactic dust, gas, and asteroids. Even more exciting, you can find other planets. Planets that aren't in our own solar system are called exoplanets. This just means that they orbit a star outside our solar system. Some exoplanets in our galaxy that resemble Mercury and Venus, although Mercury and Venus are not exoplanets because they are not outside our solar system, are very hot. Other exoplanets, like those that resemble Jupiter, are just gas giants with no solid surface. But there are areas within the cosmos of our own Milky Way where the conditions are just right. NASA has discovered several exoplanets that lie in the habitable zone, the distance from a star where temperatures could allow for liquid water to exist on the surface. These planets are also about the same size as Earth and have a rocky surface just like Earth does. Out of the 4,000 exoplanets discovered, there are about 49 to 53 planets that could have the potential to harbor life. Let's investigate two of these planets a bit further. Proxima b. The planet with the most potential is Proxima b, an Earth-sized planet that just so happens to be the closest planet to us at only 4.24 light-years away. Even though it orbits around its star in just under 12 days, Proxima b's star is much smaller, dimmer, and cooler than our Sun. The habitable zone in Proxima b's case is actually 25 times closer to its Sun than Earth's habitable zone is to our Sun. One factor that may complicate the development of life of Proxima b is that it has taken a beating from solar radiation and stellar flares. TRAPPIST-1e. Another planet that scientists believe may be able to support life is TRAPPIST-1e. This planet is one of 7 other Earth-like planets in another solar system, but TRAPPIST-1e lies within the habitable zone of that solar system. However, it is still yet to be discovered whether this planet in fact contains liquid water on its surface, or below the surface for that matter. In addition, this planet, along with Proxima b, is tidally locked. This means that one side of the planet always faces the Sun, making that side perpetually hot, and the dark side eternally cool. This means that each half of the planet experiences extremes in temperature that may make it uninhabitable for life. At least, life as we know it. However, if this planet turns out to have an atmosphere, which we don't know yet, it might even out the temperature of the entire planet, creating favorable conditions for the development of life.